relative velocity problem is a little bit more complicated than the last one. A couple of things are different. First, if you read the question, I'm not just giving you this and saying add them up. You know, here's what the plane's doing, here's what the wind's doing, what happens as a result. Here I'm doing it a little bit differently. And one of the things you'll notice is, in the question, a pilot flies a plane to a town that is 600 kilometers north, 30 east. So I'm giving you a displacement here. It's not a velocity. The velocities are usually big numbers around that amount too, so you've got to be careful and look at the units. But this is where the town is. And wants to arrive in 3 hours, so that's a time. That wasn't in our other problem either. The wind is from the west at 60 kilometers per hour. What is the airspeed and heading? Well, having this here lets me know that if I'm looking for those two things, I'm probably not given them. So let's look at this. The town is 600 kilometers away, and it's north 30 degrees east, and we want to be there in 3 hours. So that implies a velocity. If I know where a place is and how long I want to take to get there, then there must be a specific velocity required to get there. So in my equation, this is what the plane is doing, this is the result. The plane is flying and the air is moving. So I want something to happen. This velocity, I want the plane to end up going north 30 east. The resultant velocity of the plane means what actually happens. And I actually need it to go to this town. So that is the direction of the resultant velocity of the plane relative to the ground. As for the actual velocity of the plane relative to the ground, we use v equals d over t. I know how far the town is, and I know I got to be there in 3 hours. So the town is 600 kilometers. To be there in 3 hours, the velocity required is 200 kilometers per hour. So whatever happens with this airplane, the result must be 200 kilometers per hour, and it must be in this direction. Many times with relative velocity problems, the big trick is filling these in. Once you've got those, you simply plug it into your formula, you rearrange, and you solve like any vector equation. So, what else do I know? Well, I'm looking for the airspeed, that's this, and the direction that goes with that is called the heading. So I know that's what I'm looking for. And what is the air doing? Well, the wind is from the west, so it's going to be 60 kilometers per hour east, because from the west means that it's going to be heading east. I've got this, or I'm looking for that, I've got this, I've got my equation, I simply plug in. The plane relative to the ground is equal to the plane relative to air plus the air relative to the ground. So I've got this, 200 north 30 east equals, this is what I'm looking for, plus 60 east. And as I've said a number of times, here's an equation, doesn't matter that it's velocities, and it doesn't matter that it's relative velocities, I've got a vector equation, I need to solve for this. So I'm going to rearrange the whole equation, and if this stays on the positive side, this will move to the other side, so I end up with 200 north 30 east minus 60 east. So I've rearranged it. You might have to do that a couple times to see exactly how I got that. Negative 60 east becomes 60 west. So I've got two vectors here. I've got to add them up. There's a couple of ways of adding them up, but I'm just going to use components. North 30 east is 200. So I'm going to make a triangle out of that. This side is 200 times the sine of 30 is 100. This side is 200 times the cosine of 30, which is 173. Okay, now I add to that 60 west. I add up the total in the x direction. Now I have to find the resultant in the y, and it's 173 up, which is positive. So my total in the x direction is 40, my total in the y is 173, so I need to put those together. And my x and y axis, 40 to the right, y is positive 173. There is my result. So I have to find those by using Pythagoras. 40 squared plus 173 squared, take the square root. The result is equal to 178. So I rounded it a little bit. To find that angle, I find the inverse tan of 173 divided by 40. So 173 divided by 40, take the inverse tan, and you get 77 degrees. So my answer is the plane relative to the ground, or relative to the air, is 178 kilometers per hour, and this is going to be east 77 north. And I look back at the question, what is the airspeed and heading? The airspeed is the plane relative to the air, and the heading is 177 east 77 north.